Welcome to LabMinutes.com and our lab video series on MPLS. You can find your playlist of MPLS videos on our website by clicking on the link above and sign up for our newsletters to receive the latest video updates. In this video, we're going to be looking at how to configure EIGRP as the PE/CE routing protocol. And if you guys have been using EIGRP with your MPLS from the client perspective, in this video you will see how the EIGRP is seen from the provider perspective. So we start by looking at the basic configuration for EIGRP for between the PE and the CEs. Then we're going to look at some of more the advanced topic with the site of origin that would help you have a better control with some of your sites that's dual home, as well as some of the sites that has the backdoor link. And then we'll look at how the cost community plays an important role as far as the path selection. Now for a lab diagram with our physical network topology, we still have 8 routers, R1 through R8, and 1 switch 1. And comparing with what we have in the previous lab, in this lab we have made some slight modifications. And those are the new VLAN 102 right here that connects the switch 1 SVI 102 to the R2 fast 01, so that way we can have a dual home site. And we also have added a new point-to-point serial link between R6 and R7, so that way we can have a backdoor link that we can test with. But everything else as far as the physical connectivity remains pretty much the same. Okay, now for our Layer 3 topology, we still have our core MPLS network in the middle with router R1, R2, R3, R4, and R5 being either P or PE routers. But as far as our customers or VRF, instead of having 2 VRF as in the previous lab, we are now down to 1, just VRF C1, with 4 different customer sites as part of that VRF. As you can see, site 1 through site 4, with site 1 having a standalone CE router R8, and site 3 with the switch 1 is dual home to the PE router R4 and R2, and then with the site number 2 and number 4 with the router R6 and R7 that has the backdoor point-to-point link. And everything in this diagram is pretty much just been configured, and that includes the MPLS core in the middle, as well as all of the VRFs and the BGP or IBGPs. And what we're going to be configuring in this lab is the EIGRP for each of these PE and CE link for all of these sites. Okay, so let's start with our configuration task number 1 with the basic configuration of EIGRP. So we're just going to go ahead and enable EIGRP between the PE and CEs on all of these sites. So first we need to configure EIGRP with the AS number 1 on the router R6, R7, R8, and switch 1. All these are our CE devices. And we also want to include the backdoor R6 and R7 point-to-point link, and then we need to advertise the loopbacks of all of these CEs, loopback 10 through 12. Okay, and on the PE side, we need to configure R1, R2, and R4 to accept the EIGRP routes from all of the devices in the RERF C1, and then advertise them across the VPN. And then we need to make sure the EIGRP route metrics does not get altered by the MPLS VPN, and then we have to test the connectivity between all of our CE devices pretty much from their loopback 10 through 12. Okay, so let's take a quick look one more time on our diagram. Let's start off with the configuration of all of our CE devices, and that will be the R6, R7, R8, and switch 1. Beginning at router R6, we can enable router EIGRP, AS number 1, no auto summary as always, and then we're going to give it a router ID using its loopback 0. And then it's 172.16.0.6. Let's do show IP interface brief, and here we have our loopback 0.6. And then we have to enable EIGRP for R6. That would be our interface right here. This should be fast 00, and the backdoor link, which is our serial 00. Okay, so start with the passive default, and then we do a no passive on fast 00, and then on our serial 00. There we go. Then we do the network command for each of our loopback 10 through 12 that we can advertise. That would be 6600, 661, and then 662, and then our fast 00, which is 16.6, and then we have our 67.6 for our serial link for the backdoor. Okay. So you show IP EIGRP interface. You can see we have the EIGRP neighbor discovery on the fast 00 and serial 00. Okay, now going to our router R7, our next CE device. Then on R7 we have fast 00, same thing, serial 00, and then the loopbacks. So router EIGRP1, no auto, EIGRP router ID 16.0.7, passive default, no passive, fast 00, and then serial 00. As you can see, these are just the basic EIGRP configuration. Nothing is fancy about any of these configuration. Just trying to get this configured as fast as we can. Okay, so then the network, fast 00, 27.7, and then we have our backdoor link, 67.7. Since the backdoor link should be connected, and we already configured our 6 and R7, you can see we have the adjacency that came up. Okay, and R7 should be learning routes from R6, although I only see the VLAN 16 route came across, so let's go back to R6 real quick. You can see how R6 learns all these R7 loopbacks. Let's double check our config and make sure we didn't have any configuration error. Okay, looks like I make a configuration errors on the network command for all the loopbacks, so let's fix that real quick. Okay, so these ones should be 0.1 and then 1.1 and then 2.1. Okay, it's good that we check that before we move on. Okay, route EIGRP, and there you go. We got our R6 loopback 10 through 12. Okay, next is going to be our router R8. EIGRP1, no auto, EIGRP router ID 172.16.0.8. Let's take a look at the interface. Here we have our Ethernet 00, connect to VLAN 18, so no passive, and then network 8801, 8811, 8821, and then network 16.18.8. Okay. And then our last CE device, which is our switch 1, has two connections on VLAN 104 and then VLAN 102 to two different PE devices. Okay, so switch 1, router EIGRP1, no auto, EIGRP router ID 16.0.10. Then we have passive default, no passive, so VLAN 102, and the other one is 104. We have a network for the loopback 10, which is 10.10.0.1, and then 10.10.1.1, 10.10.2.1. Okay, and then you have 16.102.10. Those are the SVI 102. And then you also have a 104 for this, which is the interface right here, SVI. And then do show IP EIGRP interface and make sure our SVI 102 and 104 are enabled for EIGRP. Alright, so those are all of our CE devices. Next we're going to start configuring our PE routers. And the first routers we're going to work on is router R1 that connects to R8 and R6. And those links are on the subinterface 01.16 and 01.18. Okay, router R1, router EIGRP1, no auto. Then EIGRP router ID 172.16.0.1, which is R1 loopback 0 IP. And then we do passive interface default. And then from here on, the rest of our configuration is going to be part of the address family, IPv4 VRF. Since the routes is going to be learned by R1 from all of the CE routers, has to be placed under the VRF C1 for the routing table. Okay, so here we do address family IPv4 VRF. Our VRF is C1. And just to quickly show you, if you do show IP VRF, you can see that for VRF C1 we have fast .16 and .18 subinterfaces of being a member of that VRF. Okay, so those are already been pre-configured just to make sure now that we under the address family, VRF C1 can do no auto just to make sure, and this is where we do the no passive under the address family VRF of the .16 and .18. Okay, now to enable EIGRP in those interfaces, do a network command of 192.16.16.1. That's for the VLAN 16, and the other one is for .18. Okay, and one thing I want to point out is this AS number for this particular EIGRP routing process doesn't really have to match the other side, because this same router might be serving multiple customers that use different AS number for the EIGRP routing process. What really matters is to have a command autonomous system, although it's kind of hidden because if you do auto in question mark, all you see is auto summary. But if you type them in full, which is autonomous dash system, and then you have to give it a AS number. Number 1, this is the number that has to match the particular EIGRP autonomous system number of the peering CE device. So in our case, our CE is running AS1, so we have to define autonomous system 1. Okay, so you can see as soon as you do that, the neighbor adjacency came up. Without that command, the adjacency would not come up. So at this point, R1 should be receiving all the routes from R6 and R8 here. So if you do show IP route, don't forget to specify the VRF option, C1, and then EIGRP. You can see that the R1 is learning routes to R6 and R8. Actually, it's also learning routes to R7 because those routes are coming across the backdoor link right here. Okay, and then we also have the PEC subnet that came along with it. Okay, so now that the router R1 has those routes in its EIGRP routing table, it needs to be redistributed into BGP. Okay, so redistribute into BGP and then have that advertised to the remote sites. Okay, so we go under router BGP 100, getting under address family since we are working under VRF C1 here. So address family IPv4 VRF C1, and then you do your redistribution with the redistribute EIGRP 1. Then on top of that, you can specify metrics or route map, but we're not going to be doing it here. So we're just going to do a redistribution for all of our routes, and then enter. And you can do show IP BGP VPN v4 VRF C1, which we should be seeing all of our routes being entered into the BGP routing table. Right here, all of these has a 32.768 weight. That means those are local routes. And one thing I want to point out right here is the metrics value of each of these routes. If you compare that back to our EIGRP routing table, let's take the 6600 for example, right here, 6600. The EIGRP metrics for that is 156160, which is the exact same value because the router by default copy the metrics value of EIGRP over into the BGP metrics attributes. Same thing here with 7700. You see the value 2309120, which is the exact same value of EIGRP metrics right here. Okay, so when we jump over to the EIGRP router, we'll see how those routes actually appears in the BGP routing tables. But for now, let's move on to our next router, PE router R2. Okay, so we're pretty much done with configuration R1. Now on R2, we go through pretty much the same exercise with router EIGRP1, no auto. EIGRP router ID 172.16.0.2, which is R2 loopback 1, and then passive interface default. Next, we need to get under the address family IPv4 VRF C1, and then complete our configuration under the address family VRF with the first no auto, and then we have to do no passive on, let's see, for R2 it's going to be fast 00 and fast 01. Okay, so fast 00, pass 01. The network command 102.2. This is the interface right here, 102.2 facing switch 1. And then we need another one for 27.2, which is facing R7. Okay, same thing. We do autonomous system 1. Okay, so while we under already the routing process for the EIGRP on R2, we must well configure the redistribution for BGP route into EIGRP. So that would be redistribute BGP. Now AS number for BGP is 100. And then we have the option to provide the EIGRP metrics. And yeah, since we're redistributing from one routing protocol to EIGRP, we need to make sure we specify some metrics, although you'll see in a minute here, these value doesn't get used because the router is actually going to be using the EIGRP metrics that came across the actual BGP routes. So here it doesn't really matter. We can put like a 11111 here. And let me go back and make sure that I do the same for R1. I don't think that I did, redistributing BGP to EIGRP. Let me go back and double check before we forget. It looks like I didn't do the redistribute from BGP to EIGRP, so let's fix that real quick. With router EIGRP, and then under address family IPv4, VRFC1, redistribute BGP 100, metrics 11111, and enter. Okay, now let's go back to R2. You show IP route, VRF, C1, EIGRP, and make sure that R2 has received routes from both R7 and switch 1. Okay, and that way we can go ahead and redistribute those EIGRP routes into BGP. So router BGP 100, address family IPv4, VRF C1, and then redistribute EIGRP 1. Okay, now we do show IP BGP, VPN v4, VRF C1. Let's see what we've got here. So R2 has received the R6 loopback interfaces routes right here from IBGP, as well as the R8 routes, and then a bunch of other CEPE subnets. Okay, the first thing that you may notice is the metrics value. For example, the 6600 that we saw earlier on the router R1. Let me scroll back up right here. Originally it was 156160. You can see that on our router R2, the metrics is still the same. So the MPLS cloud itself does not really add the metrics or costs into the routes. So it could appear completely transparent to the router on each side with the exact same metrics coming across. Okay, now if you really look into this particular routes, so let me do up arrow and then 6600, you can see that there's a lot more information that we have right now as part of the extended community. Originally, it used to be just the route target, but once you use the EIGRP as the PECE routing protocol, you can see that we also have a cause value or cause community that came along with it. And as part of that, that's the original EIGRP route metric. Okay, and then some of the more cryptic or a more difficult to interpret bunch of numbers. And what these actually are is these are the composite metrics for EIGRP routes, and that way the router knows exactly how to put the route backs together and then present it to their CE routers. So let's go through this real quick. Like for example, these are some of the codes you can look up. Cisco guy or documents. They'll tell you exactly what each of these values means. And for example, right here, this value is a autonomous system number, and these are the delay value. So, and the next one, these are the combinations of reliability, next hop, and bandwidth. So again, those the 5K values. And then we also here on the right is the reserve, load, and maximum transmission unit. So right here, 1500, you can pretty much identify that as MTU. And on R2, if you do show IP EIGRP VRF C1 topology for 6600, and I'll see how the EIGRP route gets put back together by R2. And then comparing that, let me just copy this, comparing that to the originating router, which is R1. You can see that the total delay is 5100, which we have here. 5100 reliability is 255, load is 1, MTU is 1500, hop count is also 1, and then the minimum bandwidth is also matching 100 meg. So you can see that based on these values or attributes that came across the BGP route, so the R2 can reconstruct the route fully. Another important point to note here is that even though we did the redistribution between EIGRP to BGP and then back from BGP to EIGRP, the routes remains as internal routes. Unlike a regular distribution, it will cause the route to become externals. So here, this is something that's unique when you run EIGRP as a PECE routing protocol. Okay, so that should be it as far as configuration on R2. Now let's finish off our last configuration on router R4. Go to router R4 with router EIGRP1. No auto summary, EIGRP, router ID 192.16.0.4, which is R4 loopback 0. Passive default, no passive. Fast 0 0. And since the R4 is running kind of older iOS version, the passive interface is actually done outside the address family. So again, that's depending on the iOS version that you might be running. So you're getting under the address family IPv4 VRFC1, do no auto, and then do network 192.16.104.4, and that's facing switch 1, and then autonomous system 1. Okay, then we don't forget our redistribute command from BGP 100. I'm just going to do metric 11111. Okay, it doesn't matter, just need to put something in there. So the route gets advertised, and we do the show IP routes, VRF, C1, EIGRP. And here are for seeing routes to switch 1, right here, coming in this way. Now for the router BGP 100, get under address family IPv4 VRF C1, then we can redistribute from EIGRP1 to BGP. Okay, we're going to show IP BGP VPN v4, still good, it's BGP routes, VRF C1. And here R4 is learning routes to R6, R7, R8, as well as actually the routing to switch 1 itself. In addition to the route it's learning locally from the switch 1, it's also learned that same route from R2, which is this way. So R2 also advertising the switch 1 routes to R4. So at this point, we should have a full connectivity between all of our CE devices, and we can quickly verify that. Starting off with our, let's see, router R6. So let's go to R6. Right here, do a show IP route EIGRP, and you can see all of the routes that R6 is using are coming from the MPLS, as the interface is fast00, which is this interface right here connected to R1, even though the R6 has a backdoor link to R7. The loopback R7 loopback 10 through 12 routes are actually being preferred over MPLS than over the serial point-to-point backdoor link. Okay, we will look at the backdoor link in the particular in the next task. Okay, so now let's do a ping from R6 to the rest of the CE devices. I already come up with a tickle script that I can just copy and paste real quick. That will ping basically all of the loopback 10 on all of the CE devices. You can see that we have a ping reply or successful ping on all of them. Okay, so that's for R6. Moving on to our R7, show IP route EIGRP, enter. And same thing here with R7, most of the routes are being preferred over the MPLS, except for these two subnet right here. And those are the VLAN 16 and 18 on the right hand side. That's being preferred over the point-to-point. And now if you test the connectivity, you can see that the R7 loopback 10 can also ping pretty much all of the CE devices. Now jumping over to R8, show IP route EIGRP. Okay, and R8 also has routes to R6, R7, and switch 1. Here, since the tickle script it's not supported, you can just do a manual ping 6601, sourcing from loopback 10. You can see that's pingable. 77 is also pingable. 88, not quite. 88 should be pingable as well, which is itself, and then 10.10.01 is also pingable. Okay, the last CE device that we want to verify is switch 1. You show IP route EIGRP. And since the switch 1 is dual home to R2 and R4, you can see that for most of the routes, it has the equal cost path for those coming from VLAN 102 and 104. Okay, you can see all of the EIGRP metrics are identical. So it's just going to basically do a load balance out. Again, if you do the ping, let's try to source from loopback 11 also, and that is working. And 77 is pinging, as well as the 8.8.01. Okay, so at this point we have completely configured EIGRP for all of the PECE connections that we have here. And we have also verified reachability, and that's pretty much completes our task number 1.